Alright, thanks all for coming. So this is my talk on malicious behavior detection with WMI. We're going to start with a little caveat. I'm not quite sure on the timings. This could be a 20-minute job, could be a 5-minute job, but it's lunch next, so hopefully I'll get you all out and you can all be happy and get to lunch early. Alright, so who am I? I was a computer science and maths graduate, graduated in July from the University of Manchester. I've been an intern at NCC Group since just over 2 years now. And on Monday, I'm going to start a proper job, become an adult, go into the big wide world. And this photo is of me from a week ago when I was jumping off a tower in Australia and hoping that the rope didn't snap. Otherwise known as bungee jumping. And I'll say I was less nervous about doing that than I am stood up right now. Alright, so what's this talk going to be about? This is going to be part of the research of my final year project at university. So what I did for my final year project is I created a rudimentary detection system built around WMI and tried to get a bit of a better idea about how WMI works, but also what are the problems, how do we tackle some issues with when it comes to detecting. And I especially focus on living off the land binaries or lol bins. So if you don't know, these are binaries, executables, which you'll find on the Windows operating system every day. They come with the build. And your normal use of them, they're pretty standard, they're not going to do anything, but people find ways of abusing them or using them in a way to try and do malicious activity. So, what is WMI? This is probably the toughest part of it because it's not exactly a nice, simple concept to work with. So the easiest quote that I got was, it's an interface for applications to access data provided by the operating system and hardware components. So what does that mean? Well, it's just a shit ton of data. It's basically, you've got every aspect of the operating system that you think. So you've got your processes, services, your startup commands. If you can think of it, there's probably an object which WMI represents for it. And these objects have properties associated with them. And we basically have all this data all jumbled together. And then we've got ways of working with it. So we have protocols to transmit the data around. And we have this service that runs. And this service manages stuff and handles the execution around it. Alright, so what was the most useful thing I found for when creating this detection system was how do we query the data? Now to do this, WMI has its own query language. It's called WQL, very similar to SQL. It's got a few keywords that are different and it doesn't have a lot of the more useful features like joins and unions and that kind of thing. But for all intents and purposes, it's pretty useful. And we have these two objects here. These are the event filter object and the event consumer object. Now, what we can do with these is the event filter. We give it a query, and what the service will do is the service will run. It will query for. It will look for this query and it will return the data. Now, what are we actually querying for? Well, if you have a look at the photo on the right, you'll see with the query. So that is looking for the instance creation of the process objects that is named like PowerShell. So it's pretty simple. We look for instances created, modified, or deleted. And then we can pick one of these objects which represents some part of the operating system. And it will return any data. So in this case, it will return any process which has got starts with the word PowerShell. What does the event consumer object do? Well, the event consumer object can be linked with the event filter, and this will run on the query data, on the return data from the query. So what we can do is we can run scripts, we can run command lines, we can log events, we can send emails through it. This is all linked together with the filter to consumer binding object, which just links the two. So the service will run. It looks for the event filters, it queries for the data, any data that's returned, it passes it to the event consumer runs. So the example on the right, what we're doing here, so we're querying for any PowerShell object, with process object of the name PowerShell, and then we're going to run this VB script on the return data. So looking at all this is where I got the idea of creating detection. We've got a lot of data, we've got a way of querying the data, and we've got a way of acting upon the queried data. So we can query for events, and then we can act upon them, and that gives us the basis of some form of detection system. So, how is this going to run? Oh, no, I missed it. So, the bit on the right is what we call a MOF file, so managed object format. Now, this is how we create objects, or one of the ways of creating objects to add to the WMI repository where all the data is stored. And this is just a standard format. What we do is we write it, this is a text file, we'd write it, we'd then use a utility that comes with Windows called mobcomp, run that through, and it will compile the text, it will put the objects into the WMI repository so they themselves can be queried, the WMI service, that can look at them, we can read them, and this is the main way we can use to run things through. So, the detection system, back to this bit. So what we're going to do? Well, we're going to create some MOF files. So for each rule, if you like, we're going to create a MOF file. We're going to have an event filter, which is going to poll for some suspicious event. This might be like process creation, service creation. It might be DLL loading in. It could be a various different things. Any data that returns, that's just, we're going to run our VB script with it. The VB script can perform some additional checks if needed. It might be that we think it's a little bit suspicious, but we want to try a little bit more. We've got a bit more functionality by running the script. And then what we're going to do, so we're going to compile this MOF file. It's going to go into the WMI repository. The service is then going to poll for it. It's going to go through. It finds the event. It runs our script. We log the event. Bish bash bosh, sorted. So this is a crudely put together diagram which I built with word art, with MS Word, kind of describing what it's doing. So we're going to have our detection system, it's going to create the MOF file, it's going to work within the WMI architecture, the service is going to run, it's going to execute our script, it's going to write to our MOF file. So, what sort of things are we going to be detecting? So I kind of split it into some more simple rules, and then some more kind of complex rules. So when we're talking about simple rules, we're just looking at things that are happening, the behavior of stuff happening at one time. So this might be looking at command line arguments. Like I said, so these liblock-line binaries, their normal use is fine, but it's when attackers trying to abuse them, that's when we're looking for suspicious events. And one of the ways of looking at that is understanding how it's being ran. And a good way to understand how it's being run is what command line arguments are being used. So a great example of this, it might be a PowerShell is being run and someone's using the dash exec bypass. That might be a normal, or it might be, but it's an indicator. It's one of the indicators that might have something suspicious being happen. Or it might be running an encoded command. Again, it could be normal, but it's an indicator of suspiciousness. And there's loads of other examples. For this, I'm probably going to use PowerShell the most, just because it works well with a lot of the examples, but I'm sure with a little bit of thinking, you can think of some other things that could be happening. Next one that I looked at was looking at parent processes. So we're looking at not what's being run, but what is running it. So again, I'm going to use the example of PowerShell. If PowerShell runs normally, it might just run, its parent process is going to be explorer.exe. That someone's just clicked on the PowerShell icon, opened it up. But it gets suspicious when maybe you get Word or Excel spawning PowerShell. You're probably going to have some kind of malicious macro in there. And then you can look at other examples of kind of the hierarchy of processes. So what's calling what? So an obvious way around this would be you just call explorer.exe and PowerShell.exe. That would get around the first rule, but then you're looking at explorer.exe, that's being run from, say, from CMD. So, that's suspicious. So it's all about looking at the behavior of how the process is linked together and what parent process does what. And finally, another simple rule would be DLL loading. So we're going to look at what DLLs are being loaded into the process. So this is the query right at the bottom, and uses a slightly different type of query. We'll see from the top two, they're both looking for the instance creation event. The bottom one isn't looking for the creation of something. It's got its own event. It's the module load trace, which is an event that comes up every time a DLL is loaded into a process. So what this will return the name of the DLL being loaded and the name of the process it's going into. So the system.management.automation DLL is, I would call it the PowerShell DLL. It's basically if you're running some kind of PowerShell commands or you're hooking into that functionality, you're going to need this DLL. So obviously, if PowerShell is loading it in, that's fine. That's normal behavior. But you may look at other processes loading it in, and you're thinking, yeah, that's not right. Something dodgy is going on there. I'll give an example of that a little later on. And then we have, so there are our simple rules. And then I don't have any examples for these, but we have some ideas of some more complex rules. So these are when you're looking at maybe a bit of a wider picture. You're not just looking at what's happening at a very short period of time. And the first one is looking at frequency-based rules. So this is where you're looking at an event if it's just happening once, it might not be suspicious. If it's happening a lot of times in a very short period of time, then that might be something that you're looking at. And you can run all that with these WMI queries. So there's a special clause called having, which is where you do like a select your event within clause. Within keyword is all about the period of time that you're looking at. So within one means within the last minute. And if you then add having, it may be having 100, and that's saying this event's happened 100 times in the last minute. Maybe that's something suspicious. And finally, linking rules together. So again, one process doing one thing might not be suspicious. Multiple processes doing slightly different things. So you might have the creation of a file. Say someone's written to a DLL file to disk, and then they've run DLL. Well, maybe that might be a suspicious event. They're not exactly. You're not exactly looking at that happening a lot. It might be someone's dropped their malicious payload and then using one of these lol bins to run it. So you can create rules like that by linking them, adding some like logical operators into your commands, into your queries. You can get pretty intense with it. They can be as long as you want. There's no limit to them. You're just limited by the few keywords that you have. All right, and yeah. Like I said, a pretty short one. But yeah, if you want more, there's my GitHub there. There's the whole project's up there. There's a nice long read of the report, which goes into a lot more detail that I've gone in today. And yeah, there's some other cool stuff. One example that I will give actually, I was going to have a demo video, but I've forgotten the password for the VM with the video. So yeah, what I've just done. All right, it doesn't matter. We'll roll with it. So yeah, the demo video. What I was going to show is going to give you an example of the DLL loading one. And this is probably the most fun part of my project was working out how I'm going to demo this, because it's not something that you see a lot kind of thing. So the way that I worked with it is I created a malicious macro. Well, I created two malicious things. I created a malicious.NET DLL, which I had to make, which was an unmanaged DLL, so it could be loaded in by another process. And I created a malicious macro. And the macro was a one-liner thing. It loaded in this DLL and ran a function. This function executes on PowerShell. And what that meant is the macro had full capabilities of your PowerShell commands. It could run your malicious payloads and all this kind of thing. But it never actually used PowerShell. If you looked at your Process Explorer, PowerShell was never called. It was literally just all coming from, it was all Excel.exe. So this is there's not a lot of indicators for something going dodgy there, apart from the macros being run. So what we have there is an example of the DLL being loaded in. And what would happen is that module load trace event would be called. system.automation.management has been loaded into excel.exe. That's suspicious, and we would have it detected. It's a lot more interesting in the video, but I don't have a memory for good passwords, so unfortunately I can't do that. But anyway, thanks all for coming. I hope you've enjoyed it, and I hope you get out for lunch early. Thank you. Any questions? Go on then.
See, when you're like testing, did you find any issues like false positives?
Yeah, so testing it was quite a lengthy process, especially some of the DLL loading rules. That was basically run a rule, look at my logs. I would have maybe like at one point I just had it running for about a minute, and my log file had about 1,000 entries. So I had to go through and work out, all right, what is this process doing? What is this? One of the big things is there's a kind of a background process that pre-compiles a lot of .NET DLLs. So I didn't know this existed. So when you're looking at DLL loading, this will always load it in because it will do a little bit of pre-compilation before another process needs it. So you'd have to whitelist that one and then look back through your logs and whitelisting it. It's quite an intense process.
So obviously your whole thing centers around detection. If you wanted to say build some prevention element in there, would that be possible, or is it?
Yeah, so mine was detection. I was just writing to logs. I was kind of restricted by just having VB scripts. That was pretty much all the execution I had. It's not a nice language to write in. It's not. It's old for a reason. No one uses it for a reason. There is. I did found. I never implemented it, but a good way of getting around that would have been if you implemented a COM object. A VB script can then run that COM object. That COM object could have been written in C++ or in C#. That gives you a bit more functionality. You then could have looked at some more prevention stuff. So this process is running. We think it's dodgy. All right, let's kill that process. Or looking at more proactive things than just writing to a log file. That using the COM objects and stuff would also be a good way of you could hook into the actual Windows notifications. So when a suspicious event occurred, you could pop up a notification, get someone to check it manually. Carl's never really got around time constraints at uni because I didn't have time to implement that fully. But it's definitely something that I'm going to have a look at eventually.
Yeah. How do you feel with morphic things? So if it was changing its process name regularly, if it was using its own code?
Yeah, So the big downside of this is it is reliant on the process name. So if someone's changing the process name, you're going to get around that. And I did realise this. A bit too late on. But there are other indicators you could have a look for. You could then even go to the thing of creating an event for there's a file modification event. So if someone's saying, all right, I want to run PowerShell maliciously, I'm going to change its name to, then maybe you look for a file modification of someone changing the name of exes or DLLs or something like that. And you create that would be another rule and another suspicious event that you'd pick up. So people changing the names of system files or stuff like that. That could all be detected using the same WMI queries, adding rules, that kind of stuff.
So the best way to defeat it is to copy PowerShell to be I am legitimate. Exit, run that locally. Job done. It doesn't pop up.
You could. The thing is, that you'd then have a look at. So I'm pretty sure that
legitimate. Exit would be called by something else, and you think, I don't recognise that file, but the actual file could still be the same. So,
but that would get picked up by adding some file, someone modifying. So the file modification didn't just change names. It's if someone's copying stuff, like I said, or deleting stuff. It says the detection's as strong as the amount of effort that you want to put into creating rules, kind of thing. So you would have to protect your system file, doing stuff like that. to stop people doing stuff like that, you'd add other rules which detected people doing it in the first place. But if you just had the basic rules that I demonstrated today, then yeah, you're right. Someone copied the thing, changed the name, then easy job.
Hey.
I think we've got like a minute left, so I've got like one question maybe if you don't want to run away for lunch. Great stuff. Thank you very much.